Okay, number 3, create an example of the difference of two squares, then factor it. Then FOIL your factor results to show you get the original example you wrote. Okay, so difference of two squares, we're going to be subtracting two perfect squares. Okay, and you guys have a whole worksheet of examples to work off of. So just coming up with perfect squares, let's say 81 x squared plus, oh, it's a difference, so it should be minus, let's say 144. Okay. So now we can go ahead and write this. We know 81 is a perfect square. That's 9 squared x squared minus 144 is just 12 squared. Okay, so we rewrote the problem just so we have everything is squared. It's the same value here. We still have 81 here, and we still have 144 here. Okay, now I'm going to rewrite this as 9x squared, right, for the rules of parentheses. We still have 81, and we still have x squared, minus 12 squared. Okay, so still have a difference of two squares, and we're going to just rewrite this, put our answer down. So this is going to be 9x plus 12 times 9x minus 12. Okay, difference of two squares, you're always going to have one plus, one minus. Okay. So we created our examples of the difference of two squares, and then we factored it. So this was all factoring. Okay, now we're going to FOIL your factor results to show you get the original example you wrote. Okay, so now we just got to take this and FOIL it back up. So I'm going to rewrite it here so we can do our foiling. We have 9x plus 12 times 9x minus 12. Okay, and foiling, we're going to take that 9x and distribute it to both terms. Then we take that 12, positive 12, and we distribute it to both terms. Okay, 9x times 9x gives us 81 x squared, right? 9 times 9 is 81, x times x is x squared. 9x times negative 12, right? 9x times negative 12 gives us negative 108x. Okay, now moving on to the 12. 12 times 9x gives us the positive 108x. And positive 12 times that negative 12 gives us negative 144. We combine our like terms. These two here are like terms. They're both x's, and it just so happens that they cancel each other out. Negative 108 plus 108x is 0. So we're left with 81 x squared minus 144. Okay, so when we FOILed it, we did get the same problem that we started with.
Next up, it says two students are given the equation x squared minus 18x plus 91 to factor. So we have student A who claims x minus 9 squared is the factored version of the equation above. We have student B who claims it's x squared minus 9 squared is the factored version of the equation above. And then we have student C who claims the given equation is a perfect square trinomial. So who is correct? And defend your conclusion mathematically. So defending it mathematically means that we have to go ahead and solve this out. So if we're looking at our quadratic here, A is already 1, so we can go straight to doing our diamond. So what multiplies to 81 and adds to negative 18? We're looking for those two numbers there. And it's negative 9 times negative 9. So now when we go to write our answer, or our factors, we have x minus 9 times x minus 9, which we can rewrite as x, let me use a different color here, as x minus 9 squared. So now when we look at the claims, we check to see which of these students is correct. So now if we look at the students, student A has the same exact answer that we're looking for here. So student A seems to be correct. And it just so happens that student C is also correct because this actually is a perfect square trinomial. We got the same binomial squared that gives us a perfect square trinomial here, right? Because we have the 3 terms here, and it is a perfect square according to our factor here. So both student A and student C are correct.
Okay, the quadratic equation 5x squared plus 17x minus 12 has 2 x-intercepts. So we know that the discriminant is going to be positive. So now, using your knowledge of finding x-intercepts, use factoring and the quadratic formula, reveal the x-intercepts using both methods. Okay, so we got to do both methods here. We got to do factoring and quadratic formula. So looks like factoring has to go first. So we have our quadratic here. We have 5x squared plus 17x minus 12. So now the first thing we look for, is there a common factor between these 3 numbers? And no, there isn't. 5 is a prime number and so is 17. We can't pull anything out of here. Next step, we have to take our 5 and multiply it to that negative 12, right? We want our a to be 1, so we have to do multiplication as our first step. So now rewriting this, we'll have x squared plus 17x minus 60, right? Negative 12 times 5 is that minus 60. Now we have our a as 1, and we can go ahead and do our x. So what multiplies up to negative 60 and adds to 17? After putting some thought into it, it is 20 and negative 3. 20 times negative 3 is negative 60. 20 minus 3 is 17. So I'm going to go ahead and write the factors to the right of this. So we have x plus 20 times x minus 3. And I took those just from here. So now remember that we did multiply by 5 for that first step, right, to get a by itself. So we have to undo that multiply by 5 in this step. So now we're going to go ahead and divide by 5, divide by 5. Right, we're going to divide both factors by 5. And divide, if it divides evenly, you go ahead and just rewrite it. 20 divided by 5 is 4. So we have x plus 4. That divides evenly. 3 divided by 5 does not divide evenly, so that gets shot out in front. And we have 5x minus 3. Right, that's not a fraction we can reduce, so you just shoot it up in front. Okay, and now to find the x-intercepts, we're going to take each of these and set them equal to 0, each of our factors. So we have x plus 4 equals 0, and we have 5x minus 3 equals 0. Okay. So for the first factor, we're going to subtract 4 on each side, and we get x equals negative 4. That's our first x-intercept. For the other factor, we're going to add 3, we get 5x equals 3. Then divide by 5, and you get x equals 3/5 or 3 divided by 5 is 0.6. Okay, so when we factor, we got x equals -4 and x equals 0.6, and those are both our x-intercepts. Now, using the quadratic formula, we're going to make a list of what a equals, what b equals, and what c equals. So looking back at our quadratic, a equals 5, b equals 17, and c equals -12. So remember the quadratic formula, which is something you should have written down in your note card, is -b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. And then we just plug in all the information that we have. So we got to bring the negative from the quadratic. B is 17 plus or minus the square root b squared, which is 17 squared, minus 4 times a, which is 5, times c, -12, all divided by 2a. 2 times 5. A is 5. Okay. Now we do our simplifying. We have -17 out in front, plus or minus square root. Let me pull out my calculator. 17 squared is 289. -4 times 5 times 12 is 240, and it's a positive 240, so it's plus 240, right? Because you end up with the negative times the negative. All divided by 10. Okay, simplifying one more time. We have -17 plus or minus the square root of 529 divided by 10. Next, we want to check if we can simplify our radical here. So if we do plug in square root of 529 in our calculator, it turns out to be a perfect square. So this turns out to be -17. Let me draw a line here. So turns out to be -17 and then one more where it's, I'm just going to go ahead and split them up right now. But the square root of 529 is 23. Okay, so we have -17 plus and minus 23 divided by 10. And using our calculators, let's see, -17 plus 23 gives us 6. 6 divided by 10, that equals 0.6. -17 minus -23, that gives us -40, divided by 10, that gives us -4. Okay, so I know it kind of ran out of room a bit, but those are going to be our two x-intercepts, 0.6 and 0.4. So now we look, did we get the same x-intercepts when we did it both ways? So we did get 0.6 when we factored, we did get 0.6 when we did the quadratic formula, and we do get -4 and -4 when we do them both ways. Okay, so that's a way of knowing that we did these right, because our x-intercepts should not be different when we factor and when we do our quadratic formula.